See, unit 1, whatever the I conducted each and every point in during lectures that you read from BL Thareja. Numerical, for numerical practice, refer that local author book, and same type those who are interested can solve from BL Thareja. See, this one I shared with you. Do this one. Then again for unit 1, this one also I shared, charging and discharging of a capacitor. This one PDF. And this local author, DC circuit. In this, various numericals are there, enough numericals are there. Again, these handwritten notes, you can find each and every topic we have covered. Okay. So see, yesterday on Google Classroom, or I think yesterday or the day before, I posted BL Thareja volume 1 and volume 2 link. Using this, you can use this book. Using that links, you can download the books. Now, see, only transformer is there in volume 2. Otherwise, the rest, everything you will find in volume 1. So transformer unit 3 is there in volume 2. The rest part, that is unit 1, 2 and 4, completely it is there in volume 1, BL Thareja. Okay. Now for unit 1, we'll see. For unit 1, see, on every unit I told you that is 5 questions, easy level, 1 mark each. Okay. Then 3 questions, moderate level, 2 marks each. And on same unit, that is 2 questions, difficult level, 2 marks each. It's like this. How many marks? 15 marks for every unit. Means total 30 marks in same, 30 marks end same. That is 60-60. Isn't it? Sorry, 30 plus 30, 60. Total 60 marks. And on every unit, how many questions? 5 plus 3 plus 2. Means 10, isn't it? 10 questions on every unit. So like this, everything you have to finish in 2 hours. Okay. So see, in first unit, whatever, read the statement. Based on read the statement of Kirchhoff's current law, Kirchhoff's voltage law, superposition theorem, Vennens theorem, and Norton's theorem. Like Kirchhoff's means which one of the following statement is true? Kirchhoff's voltage law, that is in every electrical network, in every closed loop, algebraic sum of voltage sources, voltage drop is 0. Like this. Which one of the following statement is true? So read karo and understand karo. Ohm's law, KVL statement, KCL statement, superposition theorem, Norton's theorem, Vennens theorem. Read the theorems. Based on theorems, questions will be there. Then next one is, we have seen various terms in this. Like see, suppose 3 resistances connected in series, or 3 resistances connected in parallel, or 2 resistances connected in parallel, or 2 resistances in parallel in weighted on right hand side, left hand side, one resistance in series. Like this, simple circuits will be given means for 1 mark. And you will get asked, calculate the total equivalent resistance, current flowing through each resistance, voltage drop across each resistance. That all of you can do now, because we have taken series connected resistance, total equivalent resistance, total current, voltage drop across each. Same for parallel also. Current flowing through each, voltage drop across each, total equivalent resistance. So 1 mark. Got it? Okay, so like this, simple circuits given to you. See, here 3 are in series, here 2 are in parallel, or maybe in series with it 1 resistance, here 1 resistance. Find out R equivalent, find out total current, find out voltage drop across any of, find out current flowing through any, isn't it? Here also, voltage drop across any, current flowing through any. Either 2, 3 are connected in series, or here in series. Means like this question for 1 mark. Okay. Then based on statement, MCQ question for 1 mark. Okay. Voltage division rule, current division rule. See, this one is current division rule. In some numericals, maybe you have to use current division rule or voltage division rule. Okay. See here, voltage division rule we have used. Okay. Then next is this one we have seen. How to replace resultant, that you know. Next topic we have seen open circuit. Suppose somewhere here one circuit and find out the voltage across A and B. Suppose short circuit is here, find out the voltage across A and B. MCQ question, isn't it? For short circuit, how much current will flow through 2 ohm? Okay, like this. Or how much current will flow through this short circuit branch? 1 mark question. What do you mean by loop? Read the definition of loop, read the definition of node, electric circuit, electric network, MCQ question 1 mark, open circuit electric network, closed one electric circuit, node or junction where 2 or more than 2 branches meet together. Means this is the closed loop, closed path, closed path, that is called as loop. Okay, branches, read these definitions, 1 mark question. Then see, this is about the 1 mark questions. Again, suppose simple circuit is there like this. This is simple circuit. So using Kirchhoff's law, find the current flowing through R4 like this. Means this voltage is given R1, R2, R3, R4 given. Using Kirchhoff's law, find current flowing through R4. Options given to you, tick the correct option. Okay, here also using Kirchhoff's law, find current flowing through R3 because it's a simple circuit. Next topic we have seen about the superposition theorem. After Kirchhoff's law, superposition theorem we have seen. Let me open it, superposition theorem document.
मैम स्क्रीन ब्लैंक हो गई है.
Okay, now can you see?
Yes ma'am.
Attendance I posted in chat box. Everyone can mark na attendance.
Yes ma'am.
Attendance link. Again, I posted. Everyone, please mark your attendance. Okay. Next topic is superposition. So see, superposition theorem. Now here, see this one numerical. We have seen 2 numericals. We have seen on superposition theorem, isn't it? This is the first one. So here, what is this? This one we do. This one also done. Okay, so superposition theorem, see here, if you remember what we do, we consider here given load resistance is given to you. If you get asked, find out the current flowing through 1 ohm resistance here, means 1 ohm resistance you have to consider as load resistance. Okay, or directly it is given sometimes in the numerical that consider 1 ohm as a load resistance, or they ask find the current flowing through 1 ohm resistance, means 1 ohm you have to consider as load resistance. Okay, so here using superposition theorem you have to simplify this. So we have seen, first of all, see, we considered 100 volt voltage source, rest sources we make inoperative 50 and 40. Then we find out IL dash, which is only with 100 volt. See this one. Then we considered only 50 volt. Using 50 volt, we have find out IL double dash. The rest 2 as voltage sources, we make them short. Okay, so see here IL double dash we got with only 50 volt. Then with only 40 volt, IL triple dash through 1 ohm. In every case, this one IL double dash, see, with only 50 volt through 1 ohm, IL dash with only 100 volt through 1 ohm. Okay, so IL dash with only 100 volt through 1 ohm, IL double dash with only 50 volt through 1 ohm, and IL triple dash. Okay, IL triple dash through 1 ohm with only 40 volt. And then we make their algebraic sum. See here, we make their algebraic sum and we find out the current flowing through 1 ohm resistance when all 3 are there. Okay, so if this one is lengthy, this type sum is lengthy because 3 sources it has. So not complete one, you will get asked for 2 marks. What they will ask you, the question will be like this. Find out current flowing through load resistance 1 ohm considering 100-volt source at a time. Or find out current flowing through 1 ohm resistance with only 50-volt voltage source, or find out current flowing through 1 ohm with only 40-volt voltage source. Means not IL directly they will ask you, because the sum is lengthy. So not for 2 marks. So you will get asked either to calculate IL dash or IL double dash or IL triple dash if sum is lengthy. If some circuit is very small, then only then this IL. Okay, if only 2 sources are there, one we have seen on superposition, one more is there, no? One more document is there, 1 minute. Not here, I think. Superposition, we conducted one more, no? So this, 1 minute, it's opening. If you get asked only to find out IL dash, IL double dash and IL triple dash, then compulsory here superposition theorem you have to use. But suppose this one circuit is given and you get asked calculate the current flowing through 3 ohm resistance using either superposition or Kirchhoff's, so any or Thevenin's. But you have to type only correct answer, isn't it? So any method you can use, although they mention Kirchhoff's superposition or Thevenin's or Norton's, but any method you can use. But if they ask you that considering only 10 volt, find out the current flowing through 3 ohm, then compulsory you have to go for superposition. Got my point, everyone? Okay, what I am telling, hope all of you got it. Okay, so considering 3 ohm as a load resistance, find out the current flowing through it using superposition. Then here IL you have to find out. Means only with 10 volt IL dash you find out first, with only 6 volt IL double dash you find out, and then their algebraic sum you do, and then find out the total current flowing through 3 ohm. Okay, so like this about the superposition theorem. Then I think in superposition we have considered another sum also, isn't it? Second sum. See this one. See here. Now here 3 ohm is a load resistance. So what you may get asked, like only with 5 ampere, considering only 5 ampere current source, find out the current flowing through 3 ohm resistance using superposition theorem. See here, we have find out only with 5 ampere IL dash, isn't it? IL dash we have find out. Or another question, only with 20 volt as a voltage source, only with 20 volt as a voltage source, find out current flowing through 3 ohm resistance. So means using superposition theorem, means IL double dash you have to find out. See here, 5 ampere we make open. Are light on. Hello students, can you hear me? हेलो
यस मैम.
हाँ, वो मेरे तरफ अभी पावर फेलियर हुआ, मैंने ये मोबाइल डेटा ऑन किया है. अगर डिस्कनेक्ट भी हो जाती हो तो मैं फिर से कनेक्ट होंगी. अभी मैंने हॉटस्पॉट ऑन किया है तो नेटवर्क इलेक्ट्रिसिटी वाईफाई डिस्कनेक्ट हो गया था. ओके, सो सी दिस वन सम वी हैव रिकॉर्डिंग. This one sum we have seen that is superposition theorem. So in this sum, in such type of sum, you may get asked only with 5 ampere find out current flowing through 3 ohm, means IL dash you have to find out, isn't it? Or only with 20 volt voltage source find out the current flowing through 3 ohm resistance using superposition theorem, means IL double dash you have to find out, or find out the current flowing through 3 ohm resistance using superposition theorem, means IL dash first you find out, IL double dash you then find out, and then do their algebraic sum, and that will be the resultant current. So if resultant current you get asked to find out, then any method you use at the back end, because only you have to take the correct option. But only with 5 ampere or only with 20 volt, then compulsory you have to go for superposition theorem. Okay, so this is about the superposition theorem. So two numericals we have seen. Some circuits you solve from that local author book, that is more than enough. Okay, next one is Thevenin's. So for Thevenin's theorem, again the same thing. If circuit is simple like this, see this one is simple circuit, and they will means R1, R2, R3 given here. You consider V1, V2 given, and consider R3 suppose 2 ohm as a load resistance, and find out the current flowing through it using Thevenin's theorem. Again, I am telling to you, just you have to pick the correct answer where current flowing through load resistance only. Then any method you can use. But if in the options given that for this consider R3 as a load resistance and applying Thevenin's theorem, find out open circuit voltage VTH and current flowing through R3. R3 by using Thevenin's theorem. Then for VTH compulsory, you have to in the options maybe options given to you that find VTH and IL, or find RTH and IL, or find VTH and RTH. Find VTH and RTH. Then in these three, if options given to you are like this, suppose in one sum find VTH and RTH, in another sum find RTH and IL, in third one sum find VTH and IL, then compulsory in this method you have to use Thevenin's only, isn't it? But if given to you that in this circuit, suppose in this one simple circuit given, and find out using Thevenin's theorem total load current, options given to you are only load current, then any method at the back end you can use, you whatever you feel convenient. So Kirchhoff's also superposition, also Thevenin's. Got my point? What I am telling? Again, in this case also simple. That is, if circuit is small and simple that you can solve in 3 minutes, then using Thevenin's they will ask you to find out total load current. But if circuit is difficult or lengthy, then you will get either to find out only VTH or only RTH, or these two, or these two, or these two. Got the thing for Thevenin's? So for Thevenin's we have, see this one also, this type. Okay, this type for Thevenin's, see this type, we have considered. So ये simple है, तो इसमें आपको IL पूछेंगे. Options given VTH, IL, like this. So compulsory यहाँ पे आपको Thevenin's ही use करना पड़ेगा. VTH given in the options and IL, find out the IL. And for 1 mark, see VTH given, RTH given, IL given. Find out, these 3 values are given. See, these 3 values are given, find out IL using Thevenin's for 1 mark. Okay, again see this one also same type we have seen for Kirchhoff's through 10 ohm using VTH, find out using Thevenin's theorem, find out VTH only, suppose. So see VTH compulsory here you have to use the Thevenin's theorem. We have find out VTH here. We have see VTH we have find out, isn't it? Or in this circuit find out RTH only. So using Thevenin's, so voltage sources we make short, current sources we make open, isn't it? RTH we have find out, or find out the load current. So if circuit is small, then directly IL they will ask you, or any two. Okay, but if circuit is lengthy or difficult, then only find out VTH or only find out RTH. Okay, or any two. Means VTH IL or VTH RTH or RTH IL, like this. This is about the Thevenin's, and same for Norton's also. Same for Norton's also. So Norton's also we have considered the short circuit current for 1 mark. For 1 mark, this is given IN or ISC given, RN given, RL given, and find out the IL. Okay, so that current division rule formula you have to use here. This one, I think all of you remember it. See this one, isn't it? 1 mark sum, all 4 values given. Or see, in this formula, if you observe, how many parameters are there? 4 parameters. 4 parameters are given. In Thevenin's also 4 parameters are there in the formula. So any 3 are given, and 4th one you will get asked for 1 mark. And here for 2 marks, means again the same, whatever I told you for superposition and theorem. If circuit is simple, they will ask you find out IN and IL. Then compulsory Norton's there you have to use. Any two means either IN, IL they will ask you, or RN, IL you will get asked, or IN and RN. Okay. And if circuit is simple, then directly if IL they ask you, then at the back end you can use any method. Isn't it? Means you cannot skip. What is the conclusion? You have to do all 4 methods. Kirchhoff's also, superposition also, Thevenin's also, Norton's also. Because if you see the options, means sometimes they ask find out VTH and IL. Then compulsory you should know VTH. Sometimes they ask find out IN and IL, or IN and RN, or for Thevenin's VTH and RTH. Means superposition also, with only 100 volt or with only 50 volt or with only 5 ampere find out the current. Means you cannot skip this topic, you have to do that. Okay, so all things we have seen. This is about the theorems. One more topic is there in this unit, that is charging and discharging of a capacitor. So all 4 equations you do and 4 graphs. Got it? We have seen all 4 equations and all 4 graphs. See, during charging at start, what is the value of current? V by R. MCQ question, or all values given, and they will ask you at start during charging what calculate the current flowing. So use V by R. Okay, at charging, what is the voltage across capacitor? Means during charging at start, what is the voltage across capacitor? 0. What is the current at start? Maximum, V by R. Why I am telling you graphs you keep in your mind? Because once you keep graphs in your mind, all the questions you can answer. See here. How to zoom in this? 1 minute. So see here, graphs you keep in your mind, because once you keep, these are the 2 graphs for one is of voltage, another is of current, and these equation, which one is correct formula? Questions, MCQ question. 4 options given to you. During charging, which one is the correct formula for voltage across capacitor? Which one is the correct formula for current flowing through in the circuit during charging? Same questions for discharging also. Which one is correct formula for voltage across capacitor during discharging? Which one is correct formula for current flowing through circuit during discharging? Okay, all 4 formula you keep in your mind, and 4 graphs also. Why graphs? Because see, during charging, what is the at start? What is the voltage across capacitor? 0. Then what is the during charging at start? What is the current flowing through circuit? V by R. Is it maximum, minimum, or 0? Maximum. Define time constant. R given, C given, calculate the time constant. R into C. Formula is second. Definition of time constant. Which one is the correct option? Time constant is defined as either in this term or in this term during charging or during discharging. So 4 definition time constant has: 2 during charging in terms of voltage and current, and 2 during discharging in terms of voltage and current. Like see, read the definition of time constant. It is defined as the time taken by capacitor during charging when voltage across capacitor becomes 63.2% of its final value. Here when current becomes means here voltage rises, when voltage rises to 63.28% of its final value. when current decreases to 36.8% of its initial value. So confusing options given, isn't it? Same definitions for during discharging also. During discharging, how you can define it? When voltage decreases to 36.8% of its initial value. When current decreases to 36.8% of its initial value. Okay, so these are the definitions. Or suppose here during discharging, means R is given, C is given, supply voltage is given, and during discharging after 4 seconds, what will be the voltage across capacitor? Or here also V given, R given, this R and C given, and during discharging, current flowing through the circuit after 5 seconds. Same questions for charging also. Same questions for charging also. R given, C given, supply voltage is given, and what will be the voltage across capacitor after 2 seconds, after 3 seconds, what will be the current, what is the current flowing through circuit at start, during charging, during discharging, isn't it? Plus minus, that also you keep in your mind. This for current here it is plus, for during discharging here it is minus. Option given to you plus in terms of plus and minus also, isn't it? So this is about the charging and discharging. Any topic left in first unit? Have I missed anything? This one numerical we have seen. This type you solve from local author also. Okay. Any topic I forgot? Open circuit means what? Resistance is infinity, and short circuit means resistance is 0. Whenever it's a short circuit branch, maximum current flows through that, and whenever it's an open circuit, no current flows through it, but across that open circuit voltage can be there. Okay, any further topic left in first unit? What the thing what you have to prepare for first unit? Yes. For this, whatever my
Yes, ma'am. Yes, ma'am.
every point we have covered in lecture, you go through that lectures, you and a local author book material, and this handwritten notes, whatever the each and every type of numerical we have seen, and same type you practice from BL Dhareja. This is more than enough. Those who are interested, same type you can solve from that BL Dhareja also. Okay, now we'll go for second unit. Okay, so first unit, everything done. Let me close the files. See here, unit 2. In unit 2, what we have seen, first one, AC fundamentals. Okay, so in AC fundamentals, all these definitions you read. This one, relationship based on this, which one is correct formula, or if RMS is given, calculate the peak, or calculate average, calculate RMS, isn't it? We have taken this numerical, find out the peak factor, find out form factor. एक न्यूमेरिकल लिया था हमने, ये देखो ये वाला, इसमें हमने सब पैरामीटर्स फाइंड आउट किए थे. सो एनी यू विल गेट आस्क्ड फॉर 1 मार्क. कैलकुलेट आइदर एम्पलीट्यूड, एंगुलर फ्रीक्वेंसी, फ्रीक्वेंसी, टाइम पीरियड, फॉर्म फैक्टर, पीक फैक्टर, एवरेज वैल्यू, पीक वैल्यू, आरएमएस वैल्यू, पीक टू पीक. Okay, so if instantaneous current equation given to you, find out all the values. You should be able to find it out. Okay, then this one, suppose what is given here, this waveform, C, after omega t nothing is there, means this waveform has 0 value at origin, means like this it is, this form all of you know, like this it is waveform, isn't it? So for such waveform, see, 50 ampere means instantaneous value is given, and you get asked find out the time, or reverse, time is given, find out the instantaneous value. Maybe sometimes waveform given to you like this, that it is having some positive value at origin, and find out the time when its first positive peak occur. So see all of you, at origin it has some positive value, and at when this peak occurs, find out this time. This type you please do from local author book, local author material I forwarded to you in it. This type numerical is there. Please do that. Okay. So this one we have considered. Another one. This also you do, and same type you do from local author. AC fundamentals. Okay. Again here, find out RMS, peak, average. That is easy. Okay. Again, this one, polar to rectangular, rectangular to polar, we have seen. Huh? Two impedances given to you are connected in series. Find out the total equivalent. So just add them, isn't it? Two impedances connected in series in polar forms, in the rectangular form given. So how you will find out total equivalent impedance? Just add them. And options given if in rectangular, then directly this option, or options may be given in polar. So convert rectangular to polar. Okay. Again, what else in this? This one. Suppose voltage equation given to you. V of t is 10 sine of omega t. V of t is 10 sine of omega t, and I of t is, all of you know, it's a resistance. So what will be the current equation? I of t, I am sine of omega t. So suppose I of t is, this is I of t, which is equal to 2 sine of omega t. So find out the impedance. What will be the impedance here? Yes, V of t is 10 sine of omega t and I of t is 2 sine omega t. What will be the impedance? See, voltage equation is what? 10 sine of omega t. 5, correct. 5 ohm, isn't it? Resistance is 5 ohm, and as it is purely resistive, we can say Z is equals to R. So R is 5 ohm, Z is 5 ohm, isn't it? See, mostly in this unit, this in the numericals, instantaneous voltage and current equation only are given to you in most of the numericals. Okay, V of t 10 sine of omega t, I of t 2 sine of omega t. You must be able to see which type of circuit it is. Now see, here also omega t, here also omega t. Plus minus nothing is there, means it's a purely resistive circuit. So find out the power factor. If these two equations given, and what will be the power factor? So it's a resistive type, means power factor is unity. Or what will be the phase difference? Phi between voltage and current, or what is the power factor angle? So we know it's a 0 degree, isn't it? Like these questions. Or find out IM or IRMS. So voltage is given and resistance is given. Suppose this is the voltage, instantaneous voltage equation, and value of resistance given, and they will ask you find out the current, either RMS value or peak value. So you know VM is equal, VM by R is IM. Okay. And for this circuit, what is the power consumed? So power consumed is what? V into I. Which one value of V and I you will use? RMS value. Suppose instantaneous voltage equation given, that whatever I have given 10 sine of omega t and current is 2 sine of omega t, find out the power consumed. But power consumed here, V and I, which value you will use? RMS value. Unit is watt. Okay, like this. Here also, suppose same thing. See, voltage equation, current, this is the current equation. Voltage equation is V of t, Vm sine of omega t. You consider voltage is same voltage equation. That is, I will consider it now 20 sine of omega t. V of t is 20 sine of omega t. Then current equation will be what? I of t is, you consider here 5. You consider here 5 sine of omega t minus 90 degree. Isn't it? Yes. Suppose voltage equation is given 20 sine of omega t and current equation is given 5 sine of omega t minus 5 by 2 or minus 90 degree. Means what we can say here, minus sign is there. Means current is lagging this voltage by how much degree? 90 degree. Means this is which type of circuit? In which circuit current lags voltage by 90 degree?
Capacitor.
No, lags. Minus sign hai.
Inductive.
Inductive means it's a purely inductive circuit. So here find out Z. Z क्या रहेगा यहाँ पे? 20 by 5. That is 4 ohm. But Z is what here? They will ask you. Z is nothing but what? XL. Isn't it? Because purely inductive hai. ये देखो formula if you remember. V by I is what? XL. So you will get asked in this circuit. Find out the value of leakage reactance. Sorry, not leakage reactance. Which one? Inductive reactance. Leakage reactance, that is the concept for transformer. XL here is what? Inductive reactance. So how you will find out here inductive reactance? Vm by Im. Vm is 20, Im is 5. So 20 by 5. that is 4 ohm is impedance, you can say, or it is XL, or L also they can ask you here. Find out the value of L. Means observing instantaneous voltage and current equation, you should be able to find out whether it is purely resistive, purely inductive, or purely capacitive. Got it everyone? Yes, all of you getting it?
Yes, ma'am.
हाँ. और अगर यहाँ पे देखो, ये सपोज वोल्टेज इक्वेशन इज v ऑफ t 20 साइन ऑफ ओमेगा t है, और करंट इक्वेशन इज i ऑफ t 5 साइन ऑफ ओमेगा t माइनस 90 डिग्री है, तो प्योरली इंडक्टिव है. अगर ये 90 डिग्री नहीं है, माइनस सपोज 90 से लेस है कोई भी एंगल, 10 डिग्री 20 डिग्री, सपोज 30 डिग्री है, तो ये कौन सा सर्किट होगा? फिर सिर्फ यहाँ पे 90 के अलावा 30 डिग्री है, तो कौन सा सर्किट होगा? करेक्ट, सीरीज आरएल होगा. गॉट इट? Okay, so here in almost all numericals, instantaneous voltage and current equation given to you, that everyone please take care of, that if it is v of t vm sin of omega t, I of t im sin of omega t है, तो means resistance ही है. Okay, अगर v of t vm sin of omega t and I of t im sin of omega t minus 90 डिग्री है, तो ये purely inductive है. एंड im sin of omega t plus 90 डिग्री है, तो ये प्योरली कैपेसिटिव है. बट एंगल जो है ये माइनस फाइ और प्लस फाइ, अगर ये 90 से कम है तो इट्स कैन बी सीरीज आरएल और सीरीज आरसी. गॉट इट? हाँ, ठीक है. तो प्योरली इंडक्टिव में इक्वेशंस यूज चेक वेदर इन दिस फॉर्म v of t vm sin of omega t and current is this, then use this formula. Here see 3 unknown parameters. Out of these 3, any 2 given to you, third one they will ask you to find out, or L. Okay, then XL we have seen. For DC it acts as a short circuit. Okay, power factor is what? 0. Phi is what? 90 degree. Means in purely inductive circuit, in purely capacitive circuit, purely resistive circuit, whether current lags, leads, or in phase, that we have seen. No power consumption for purely inductive. Energy stored by inductor half Li square joule. Okay, same things for capacitor. If voltage equation given to you in form, suppose v of t vm sin of omega t and I of t im sin of omega t plus 90 degree, means ये purely capacitive है. So out of these 3, see, we have seen here the formula of im is what? Vm by, see, im is what? Vm by XL. तो ये जो 3 पैरामीटर्स है, आउट ऑफ दिस 3 any 2 given, and third one they will ask you, or XC once you find out, they will ask you find out the capacitance in farad or microfarad. Okay, what is the power factor? Same as that of inductor. Here power factor is 0, phase difference is 90 degree, half CV square, isn't it? No power it will consume, power consumed by it is 0, and XC is what? See this one relationship, it acts as a open circuit for DC that we have seen. Or find out the impedance, means all of you keep in your mind, for purely resistive Z is what? Equal to R. For purely capacitive Z is what? Minus JXC. Sometimes option given to you in rectangular form also, minus JXC. Or if only in polar form given, then XC is what? Vm by Im or Vrms by Irms. Can you tell me Vm by Im and Vrms by Irms, these both the ratio will be same or different? Same it will be.
Same.
Same. So XC की value you can calculate either by Vm by Im or Vrms by Irms. Same ही value आएगी. अगर options आपको magnitude में दिया है तो Vm by Im is sufficient, तो XC आ जाएगा. तो options may be only XC or minus JXC. Similarly for purely inductance, what it is? Plus JXL. Okay, so and here only, suppose the voltage equation given Vm sin of omega t and current equation given Im sin of omega t, not here plus 90 degree, plus suppose any angle less than 90 degree, suppose 60 degree, 30 degree, so it will be which one circuit? Series RC, isn't it? What the thing? हाँ, तो आपको वहां पे सर्किट क्लियरली आइडेंटिफाई करना है. तो लाइक दिस गिवन एंड देन अननोन पैरामीटर्स दे विल आस्क. न्यूमेरिकल्स वी हैव सीन on series RL, series RC, series RLC, whatever the numericals we have seen. See for series RL numericals this one theory, इसमें सिर्फ आपको फॉर्मूला ये सब लिख लो. आप जो भी फॉर्मूला है ना, इसमें which one formula suppose for RL will tell you. Voltage equation is this one, voltage drop across resistance, voltage drop across inductor, total voltage, ये मैं टिक कर रही हूँ वो formula. This is another formula. हाँ, voltage equation ये है, current equation ये है, where phi is in between 0 and 90 degree, so it's a series RL. Sometimes this and this is given to you, and then the rest parameter they will ask you to find out. तो आपको identify करना है, यहाँ पे minus sign है means current lag कर रहा है, okay, means inductor है, और phi in between अगर 0 और 90 डिग्री है तो ये series RL है, ऐसे. फिर options given to you, calculate power factor, 0.5 lagging, 0.5 leading, options given like this. So which one you will take for RL? 0.5 lagging. Okay. Power consumption, calculate active, they will ask you calculate active power, true power, real power, power consumed, power dissipated. Means what? Active power, unit ध्यान में रखो, watt. Sometimes you have to use this formula to solve the sum. Sometimes this formula, all formula you keep in your mind. Yes.
ते जे आता पॉवर तिथं लिहिलेलं होतं VI cos phi, तो V आणि I VRMS लिहू ना आपण.
Yes, RMS. RMS.
थैंक यू.
हाँ, yes. ये देखो यहाँ पे जो भी मैंने फॉर्मूला लिखा है ना, ये देखो यहाँ पे VI cos phi, VI sin phi and VI, these all are RMS value. Okay, and as how you can calculate square root of P square plus Q square. Okay, similar thing for capacitor. See this numerical, ये numerical आप solve करो, and same type from local author book. See this one also, ये दो numerical और एक दो type के उधर means active power given and then the rest. Third लिया था हमने recording में, देखो ये दो और एक तीसरा लिया था. This is more than enough. ठीक है? Okay. और ये हैंड रिटन के ये आपने सॉल्व किए, और जो मैंने क्विज में दिए थे, और एक दो इसी टाइप के आप BL ये लोकल ऑथर से कर लो, मोर देन इनफ. हाँ, सिमिलर थिंग फॉर RC. इज देयर एनी नीड टू रिपीट? नो ना. Same thing, whatever we have seen for RL, same thing you write down all formula on one paper for capacitor. See this one for series RC, where phi is this, nature of power factor leading, same formula. This one, ये मैं जो टिक कर रही हूँ ना, any of it you have to use while solving the numericals. Okay, ये this two, this one, सभी फॉर्मूला ये ध्यान में रखो. phi is negative for RC, series RC, and phi is positive for series RL, and same for series RLC. more inductive है तो phi is positive, and more capacitive है तो phi is negative. Same formula for active, reactive and apparent power. This is about RC. जो भी हमने न्यूमेरिकल लिए हैं ना, ये टाइप के, और एक था दूसरा लोकल ऑथर से, इनफ है. ठीक है? Then what else? Series RLC. Series RLC we have seen more inductive, more capacitive and resistive. So again the same thing. If circuit given to you, it's a series RLC, and then again same thing. See, series RLC दिया है और phi positive है तो more capacitive, sorry more inductive. Phi negative है तो more capacitive. And if XL is equals to XC, then circuit is at resonance. तो ये सभी formula, वोल्टेज इक्वेशन और करंट इक्वेशन हर एक इसमें नोट डाउन करो तो आपको ध्यान में आ जाएगा. समटाइम्स ओनली वोल्टेज इक्वेशन एंड करंट इक्वेशन आर गिवन लाइक दिस. सी, तो ये सीरीज RLC दिया है, तो ये सीरीज, अगर ये वोल्टेज इक्वेशन ये फॉर्म में है और मेंशन किया है कि इट्स अ सीरीज RLC, देन इट इज मोर इंडक्टिव और मोर कैपेसिटिव. सी, माइनस साइन है तो मोर इंडक्टिव. नो, RLC ही है, RLC ही है, ये सीरीज RLC है, एंड वोल्टेज और करंट इक्वेशन लाइक दिस गिवन. तो माइनस फाइव है, माइनस फाइव किस में रहता है? इंडक्टर में. इंडक्टर के केस में मीन्स ये मोर इंडक्टिव है. VL इज ग्रेटर देन VC, XL इज ग्रेटर देन XC, ऐसे बोल रही हूँ. ये फॉर्मूला लिख लो सभी एक पेज के. और एक हर एक टाइप का एक एक दो न्यूमेरिकल भी आपने सॉल्व किया है. हैंड रिटन जो नोट्स है उसमें हमने एक एक लिया है, और एक आध दूसरा अलग टाइप का लोकल ऑथर से किया तो इनफ है, मोर देन इनफ है. एनी डिफिकल्टी विद दिस? और इसमें फिर बाकी थियरी क्वेश्चंस वही रहेंगे, इन फेज, लैगिंग, लीडिंग. ठीक है? ओके. RLC we have seen at resonance, impedance is maximum, current is minimum, Z is equals to R, हाँ, ये ग्राफ एक बार ओवरलुक कर लो, दिस वन। ठीक है, एनी पॉइंट लेफ्ट इन सेकंड यूनिट, यू गॉट इट? यहाँ पे इंपॉर्टेंट क्या है कि वोल्टेज इक्वेशन और करंट इक्वेशन अगर आपको देखते हैं ना instantaneous, you should be able to identify whether it is purely resistive, purely inductive, purely capacitive, series RL, series RC और series RLC। एक important thing 1 मिनट में कवर करती हूँ, थर्ड और फोर्थ यूनिट का आप रिकॉर्डिंग पढ़ लो। हाँ, रिकॉर्डिंग सुनो जो कल आपको गूगल क्लासरूम पे मिला है, उसमें सिर्फ एक है कि वर्क पावर एनर्जी जो है टॉपिक, हाँ, वर्क पावर एनर्जी के न्यूमेरिकल आप बीएल थरेजा से कंपल्सरी सॉल्व करने हैं। हाँ, एवरीवन गॉट इट? सो ये चैप्टर है यहाँ पे सेपरेट, वॉल्यूम 1 में वर्क पावर एनर्जी। सो दैट चैप्टर यू उसमें बोलती हूँ मैं आपको कहाँ से कहाँ तक है न्यूमेरिकल्स। जस्ट 1 मिनट। हाँ, ये वाले न्यूमेरिकल, ये देखो यहाँ से स्टार्ट करना है आपको। दिस वन न्यूमेरिकल कंपल्सरी यू डू फ्रॉम बीएल थरेजा, मीन्स लोकल ऑथर तो करना ही है, जो मैंने हैंड रिटन लिए हैं वो भी करना है। अलोंग विद दैट वर्क पावर एनर्जी बीएल थरेजा जो है उसमें से करना है। ये आप डी डिवीजन के रिकॉर्डिंग में मैंने मेंशन किया है। हाँ, फिर भी आपको बोलते हो थर्मल सिस्टम नहीं करना है। ये देखो यहाँ से स्टार्ट हुआ है, ये देखो यहाँ से मैकेनिकल इलेक्ट्रिकल सिस्टम के रिलेटेड ही सम सॉल्व करने हैं। टर्म्स आल्सो यू रीड फ्रॉम मैकेनिकल एंड इलेक्ट्रिकल सिस्टम ओनली। तो ये देखो ये 3.5 बीएल थरेजा 3.5, एग्जाम्पल नंबर 3.5 यू डू दिस वन। 3.5 से लेके सब है, फिर थर्मल छोड़ के। हाँ, 3.5 से ये देखो अभी थर्मल नहीं करना है, ये सेकंड वाला आई थिंक थर्मल है। यस, डोंट डू दिस, 3.5 करना है। देन 3.7, 3.8, यस 3.8 डू इट। हाँ, 3.9 don't do, 3.9 is thermal system. Okay, then this one also you do 3.10. Then okay, तो सी थर्मल छोड़ के सब करो। हाँ, ये देखो इसमें अभी कैलोरीफिक वैल्यू वगैरह रहती है ना, दैट डोंट डू। ये वाटर हीटेड, अगर हाँ फर्नेस का है, हीटर का है तो डोंट डू। सी ये फर्नेस हीटर का है, डोंट डू इट। 3.12 यू कैन डू। हाँ, 3.12, 3.13 डू इट। 3.14 आल्सो डू इट। 14 नहीं पूछेंगे, बहुत लेंथी है। 14 यू कैन स्किप। 15 आल्सो डोंट डू, 14, 15 मत करो। 16 also not required. 13, 14, 15, 16 don't do, लेंथी है, वाटर हेड के तो मत करो। हाइड्रो पावर प्लांट के सिर्फ सिंपल है। व्हाट आई एम टेलिंग टू यू, ये जो सभी न्यूमेरिकल है ना 3.3 या 4 से हमने स्टार्ट किया है, तो हाइड्रो पावर प्लांट का सिर्फ सिंपल है, जो मैंने लिया है हैंड रिटन में वही करो। हाइड्रो पावर प्लांट का थर्मल सिस्टम नहीं करना है, वो छोड़ के फिर बाकी जो है ना वो कर लो। ठीक है, ओके, गॉट द थिंग? यस, 3.19 भी करना है आपको। ओके, एंड दिस लास्ट वन, ये लिफ्ट के करो। 3.22, 23 ये करना है। 3.22, 23, 24 you have to do this. Go through this. Any difficulty? So first और 2 का we have seen in detail. थर्ड और 4 के लिए आप वो रिकॉर्डिंग सुन लो, इनफ है वो। ओके, so any difficulty? Someone was asking for polar to rectangular, rectangular to polar conversion. So आप will you listen the recordings?
Yes, ma'am.
हाँ,
Yes,
okay. So any difficulty?
No, ma'am.
हाँ, मैंने वो हैंड रिटन सॉल्यूशन अपलोड करने के लिए लिंक पोस्ट किया है।